So for example, you're asked to find the values of k for which this expression 2kx square minus kx plus k minus 7 is greater than 0 for all x belongs to R. So if this expression has to be always greater than 0 for all x belongs to R, what should be the possible values for k? So as you can very clearly see, in the first stage, you're not asked to solve the inequality. You're not asked to solve this expression greater than 0. You're given that this expression greater than 0 for all x belongs to R. That means you're given a solution. You're asked to find the values of k for which this happens. That means you're asked to find a condition on k. So when will this expression be always greater than 0? So this expression will always be greater than 0 if the discriminant of this equation, of this expression, is less than 0. So this condition implies that the discriminant of this is less than 0 and the leading coefficient, which is also an unknown, and the leading coefficient should be greater than 0. There are two conditions for an expression to be always positive. The leading coefficient has to be positive and the discriminant has to be negative. Discriminant has to be negative. So let us apply the conditions. So 2k greater than 0 implies k greater than 0 and discriminant is less than 0. What is the discriminant? B square minus 4 into 2k times k minus 7. This has to be less than 0. Now this is a quadratic inequality. So k is greater than 0 and let us try to simplify this. K square minus 4 2s are 8, 8k square plus, so 8k into 7, 8k into 7, 56k is less than 0. So this implies k square minus 8k square is minus 7k square plus 56k is less than 0. So I'll divide it with a minus 7. So if I divide it with a minus 7, so you get k square minus 8k is less than 0. K square minus 8k is less than 0. Now this is a quadratic inequality whose leading coefficient is positive. So if you divide with a minus 7, the sign of inequality reverses. So if you divide with a negative number, the sign of inequality reverses. Now this is a quadratic inequality whose leading coefficient is positive. So quadratic inequality greater than 0 implies the variable lies outside the roots. So what are the roots of this? K times k minus 8 is greater than 0. So the roots are 0 and 8. K is equal to 0 and k is equal to 8. So if you plot them on a real number line 0 and 8, so k has to lie outside 0 and 8. K has to lie outside 0 and 8 for this to be valid. So the solution for this is k belongs to minus infinity comma 0 union 8 to infinity. And the second part of the solution is k greater than 0 and this. That means both of this have to happen. So one solution says that k has to be greater than 0 and the other solution says that k is less than 0 or greater than 8. So what is the combined solution? That is the intersection of these two solutions. This has to happen and this has to happen. So are there any numbers which satisfy both the equations? Yes. So k has to be greater than 8 is the answer. So if the number is greater than 8, both discriminant is less than 0 and the leading coefficient is also positive. Hence this condition is valid. So what are the values of k for which this is valid? K has to be belonging to 8 comma infinity. That's the answer to this question. Thank you.